conditional statement that I frequently have used at home. If you clean your room, then you can play video games. Now we need to determine when is this true and when is it not. Okay, so we have the hypothesis, which is you clean your room. And then we have a conclusion. That's a terrible, terrible line. That's better. Then we have a conclusion, and that is you get to play video games, right? Okay. And then together we have the conditional. Which is the if, room, then games.
Oh my gosh, it's raining.
Okay. So we need to figure out when is this conditional statement true. Okay, so let's say my son cleans his room. Well, then I say, okay, cool, go play video games. So he cleaned his room, and he gets to play video games. So that's true. So the room is clean, and games are played. So the whole thing is true. But let's say he cleans his room, and then I say, you know what, I changed my mind. No video games for you today. That statement is now false because I lied, essentially, right? I said, if you do this, then this will happen. Well, you did this, and now this hasn't happened, so that makes it a false statement. The room is clean, but there's no games. Okay. So if the hypothesis is true and the conclusion is false, the whole thing is false. Well, what happens if he does not clean his room? Right? But does it matter if the hypothesis is false? Does it matter about the conclusion anymore? No. Once the hypothesis is false, the statement becomes true. Because if the hypothesis is false, then the conclusion doesn't matter. So it doesn't matter if he gets to play video games or not, because the room wasn't clean, the conditions have been met. Or not met. So that makes the statement automatically true. Because the assumption is he didn't clean his room, so he didn't get to play video games. We don't actually care if he did or not. But the assumption is once this part is false, this part doesn't matter because we've made the statement true. Because the assumption is the condition didn't happen, so the conclusion doesn't happen. So no matter what happens here, once this part is false, so we have false hypothesis. The conclusion doesn't matter. The assumption is the statement was true. The original. So we have conditional statements. So P and Q, this is the hypothesis and the conclusion, and the conditional statement is P implies Q. If they're both true, it's true. If the hypothesis is true and the conclusion is false, it's false. If the hypothesis is false, it doesn't really matter what happens here. It's true. The only way a conditional statement is false is if the hypothesis is true and the conclusion is false. And you don't really even have to write these two in because they don't matter anymore. But if it's false and true or false and false, it's still true because the assumption is that if the hypothesis had been true, then it would have happened this way. But since the hypothesis wasn't true, we don't know. So we just assume that it would have gone the way we said. These are true or not. And then if they're false, we're going to come up with a counterexample. So if, and then, that's supposed to be then, okay? We look at these, if and then, and if you divide an integer by another integer. Well, we'll just go ahead and say that's true because we can divide an integer by an integer, yes. Then the result is also an integer. Do you think that's always true? Yeah, that's false. So that makes the whole statement false. And we can come up with any kind of counterexample. Let's say 5 divided by 3. So it's a fraction, not an integer. And if we did it into decimal format, it would be 1.6 repeating. Non-integer. So you can come up with any example, any counterexample. Okay. If next month is August, then this month is July. Now we'll pretend that this is true. Next month is August. Does that make this true? Okay. So then the whole thing is true. Okay. If a triangle has 4 sides, yeah, that's false. So we don't care about the rest of it. If the hypothesis is false, the whole thing is true. I know that doesn't make a lot of sense, but we just say it is. Because we assume that once the hypothesis is false, that's a not P kind of a situation. So then we assume that if the hypothesis had been true, everything would have flown the way it was supposed to. So if the hypothesis is false, we go back to saying the original thing would have been true. Because if it had been true, then both would have been true. We assume that they would have both been true. If it had been true.
So when it's false in the beginning, so it's
always true. Yeah, if the if part is false, then the whole thing is true.
So it's like a negative, like you just think it's a negative number, just trying to make it positive.
Mm-hmm.
Okay.
So if angle A is an acute angle, this we'll just say is true, because angle A could be acute. Then its measure is 35 degrees. Is that, no, that could be anything, right? So we're going to say that this whole thing is false. And give me a counterexample. $36. Yes, that would make it false. So the whole thing is false. The only way we get a false, okay, if we have true to true, it's true. True to false is false. Once you have false up front, it's always true. We don't care if this is true or false, it doesn't matter. Once you have false up front, it's true. The only way it's ever going to be false is if the conclusion is false. Okay, so related conditionals are based on a given conditional. So your conditional statement is an if-then statement. We have if P, then Q. So P implies Q. So an example would be if angle A is 35 degrees, then angle A is acute. Okay, if then. Well, a converse takes that original conditional and exchanges, or trades, let's say exchanges. conclusion and hypothesis. It flips. So instead of being if P then Q, it's if Q then P. So if angle A is acute, then the measure is 35 degrees. So we took the front and made it we took the hypothesis and made it the conclusion, and we took the conclusion and made it the hypothesis. We flipped them. Okay. Inverse negates them. But they stay in the same order. So not P, so if not P, then not Q. So not P implies not Q, so if the measure of angle A is not 35 degrees, then angle A is not acute. So same order as the original, but we just put the knots in there. And the last one we have is called a contrapositive, and this one flips and negates. So not Q, sorry, that's not even a Q. If not Q, then not P. So if angle A is not acute, then the measure of angle A is not 35 degrees. So our original statement is if angle A is 35, then angle A is acute. Our converse flips those. So if angle A is acute, then it's 35 degrees. Inverse negates them. So if angle A is not 35 degrees, then it is not acute. And then contrapositive does both flip and negate. So if it's not acute, then it's not 35. Equivalency is equality, like equal, right? So if I say something's logically equivalent, they have the same truth value. Okay. So if we look at things that have the same truth value, okay, a conditional and a contrapositive are logically equivalent. And if we look at our example, I'm just going to back up for 1 second. Here's our conditional. If the measure of angle A is 35, then it is acute. That's true. If it's not acute, then it's not 35. Also true. So the conditional and the contrapositive in this case are both true. So they're logically equivalent. Then your inverse and your converse are logically equivalent. So they'll have the same truth value as each other all the time. Sometimes the conditional and the inverse and the converse, like they can all have the same truth value, but that's not always the case. The conditional and the contrapositive always have the same truth value, and then the inverse and the converse always have the same truth value. You know how I like to think of remembering converse? You're wearing converse. Where's the star? It's on the inside. Doesn't make sense, right? It should be on the outside. It's flipped. Does that make sense? So converse are flipped, Just like the shoes, you would think that the star would be on the outside where it would be easy to see, but it's on the inside where it doesn't really make sense to be, so it's flipped. Okay, and if we look at the converse and inverse on our other example, if angle A is acute, then it's 35. That was false because it could be 36 or anything else that's not 90, that's less than 90. And if it's not 35, then it's not acute. Well, that's not necessarily true because if it's not 35, it could be 21, which is acute. So this is also false. So converse and inverse are the same truth. Conditional and contrapositive have the same truth. We can write related conditionals. Okay. So lions are cats that can roar. We're going to put that into a conditional statement. Okay. So our conditional is P implies Q. So if an animal is a lion, then it is a cat that can roar. Now, I didn't put this the other way because this is true. Lions are cats that can roar. That's true. But if I said it, if an animal is a cat that can roar, then it's a lion. That's not true because there's other cats that can roar, right? Yes. Tigers, cheetahs. Yeah. So the conditional is if an animal is a lion, then it is a cat that can roar. Our converse that's where we flip it. So Q first, then P. So if an animal is a cat that can roar, then it is a lion. I should have written that in black. Oh well. Then we have an inverse. Okay, and our inverse is negated, so it's not P, not Q. So if an animal is not a lion, then it is not a cat that can roar. And finally, we have the contrapositive. Our contrapositive is not Q, not P. So backwards flipped and negated. So converse is flip, inverse is negate, contrapositive is both. So we do if an animal is not a cat that can roar, then it's not a lion. Okay? And we can look at the truth of these. If a cat is, or if an animal is a lion, then it is a cat that can roar. True? Okay. If it's a cat that can roar, then it's a lion? No, because it could be some other roaring cat. If it's not a lion, then it's not a cat that can roar? Well, it might not be a lion, but it could still be a cat that can roar, right? Yeah, a tiger, yeah, whatever. So this one is also false. And then if it's not a cat that can roar, then it's not a lion. Think about that. If you're not a cat that can roar, can you be a lion? No, so this is true. Because if you're not a roaring cat, then you're not a lion. You're something else. Now, if you look, we had talked about this, the conditional and the contrapositive have the same truth value. They're both true. And then the inverse and the converse are both false. Same truth value. So if you can figure out the truth value of one of those sets, you know the truth of the other one. So if I know that converse is false, then I automatically know the inverse is going to be false. If the conditional is true, then automatically the contrapositive is going to be true. What is not the case is if the conditional is true, it does not automatically make the inverse false. Okay, because we have things that can go both directions, or maybe it doesn't automatically make the converse false. Like as an example, if I said if x equals 2, then 2x equals 4, that's true. If I say if 2x equals 4, then x equals 2, this is the converse. These are converse of each other, but they're both true. If 2x is 4, then x does equal 2, because I divide by 2. And if x is 2, then I multiply it by 2, I do get 4. Do you see how that makes sense? Like, so just because the conditional is true doesn't mean automatically that the converse or the inverse will be false. The only thing that it automatically tells me is if the conditional is true, the contrapositive will be true. If the conditional is false, then the contrapositive will for sure be false. And then if my converse is true, then my inverse will be true. If my converse is false, then my inverse will be false. I don't have anything that tells me automatically the relationship between those two groups just inside the group. Does that make sense? Okay, let's try another one. Two angles that have the same measure are congruent. So we'll do our conditional. If two angles have the same measure, then they are congruent. By the way, you don't actually have to spell words in here if we know symbols for them. Okay. Do you want to do inverse, converse, or contrapositive next? Okay. So our contrapositive is we flip it and we make it negative. So if two angles are not congruent, then they don't have the same measure. Okay. Inverse or converse next? Okay. Inverse is where we make them both not, but keep it in the same order. So if two angles don't have the same measure, then they are not congruent. And then finally we have the converse, which is just flipped. So if two angles are congruent, then they have the same measure. Okay. So we have conditional, which is if P, then Q. I'm just going to summarize it. The inverse, if not P, then not Q. The converse, if Q, then P. And then the contrapositive, if not Q, then not P.